Okay, so with the balancing stuff, like I said, I'm just going to go through the balancing stuff really quickly because you guys already know how to do that. We've been doing it already for many days. Okay, and then we'll move straight to the predicting stuff. All right, so key points for today. Understand that the amount of atoms on the reactant side of an equation must be the same as on the product side. That's the law of conservation of mass, okay, or law of conservation of matter. We have to conserve that. That is the purpose of putting in coefficients, okay, to help balance our chemical reactions, okay, and obviously understand matter cannot be created or destroyed. Okay, so if we're looking at, okay, the law of conservation of mass in this reaction, okay, if I start out with 2 hydrogen molecules, that would be 4 hydrogen atoms, reacting with 1 oxygen molecule, that's 2 oxygen atoms, I would get 2 water molecules. Do I have the same amount of atoms on both sides? I do. I've got 2 oxygen atoms on both sides, I've got 4 hydrogen atoms on both sides. Equation is balanced, I haven't created or destroyed matter, okay, and that's what we, like I say, we've been doing for a while now. Okay, so in which one of these pictures, that's not even going to fit on there. Okay, in which one of these pictures is the law of conservation of mass being obeyed? So A is the reactants, and then there's B, C, and D. In which one of those is the law of conservation of mass being obeyed?
D.
Okay, so in D we've got, or sorry, in A we've got 2, 4, 6, 8, 10 red ones, 2, 4, 6, 8, 10 red ones, okay, and we've got 4, 8 yellow ones, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I'd say it's D. It's obviously not C. There's way too few, okay, atoms in there, and there aren't enough of the yellow ones, right, in B. Everyone okay with that? That's pretty simplistic because, like I said, we've been doing that already for a while. Okay, so the balancing stuff, okay, we talked about the balancing stuff for all reactions other than combustion reactions. Okay, we start with the biggest number and we try and balance it, and then we go back and forth, okay, until we have the entire reaction balanced. If it's a combustion reaction, then we balance in alphabetical order and apply the rule of 2 if we have an even number of carbons. Okay. All right. I would like you guys to see what we remember from Friday, and see if you can predict the products for those 4 reactions. Okay, now I'm going to remind you here, the steps go as follows. Identify the reaction type. Use that type's pattern, okay, to put products together. Drop and swap ionic compounds. Check for special elements. Balance the whole equation. Okay, those would be your 5 steps. Identify the type, use the type's pattern to predict the products, drop and swap any ionic compounds, check for special elements, balance the whole reaction. Okay, I'll give you a few minutes on those 4 and see how we do. Okay, so on our first one here, I've got an element, calcium, reacting with another element, oxygen. What kind of reaction starts with 2 elements? Synthesis. Okay, in a synthesis reaction, what's going to happen to these 2? They're going to combine. Okay, so I'm going to get CaO. Now, what kind of compound is that? That's ionic. Okay, so I've done the steps here, right? I've identified the type, and I've used the type's pattern to figure out the product in this case. Okay, and now I am dropping and swapping any ionic compounds that are formed. Okay, so this is a -2, this is a +2, so that compound is okay the way I have it written. Okay, next step, check for special elements. Well, it was already taken care of because I got the reactants. There aren't any special elements in the products. Okay, now what do I have to do? Last thing, balance the whole reaction. I've got 2 oxygens over here. Now I have 2 on the product side. Need to go back over here and make sure I have 2 calcium, and then I'm good. Okay? Everyone all right with that?
Yep.
Okay. So for number 2, I just have magnesium sulfide. That's my only reactant. What's the only reaction type that starts with only one reactant? Decomposition. Okay, in a decomposition reaction, what's going to happen to this? It's going to split apart. Okay, so that means I'm going to be left with magnesium and sulfur. Okay, do I have any ionic compounds I need to drop and swap? No, because this one was given to me, I have to assume it was correct. Okay, do I have any special elements? That's the next step.
Yeah.
Which one?
Sulfur.
Sulfur. Okay.
8.
Now that I've got that 8 there, now I know I've got to come back here and make 8 sulfur. That gives me 8 magnesiums, so I've got 8 magnesiums, and now the reaction is balanced. Okay, everyone all right with that? It's a pretty big deal to remember to check for special elements.
Yeah.
Yeah, that would really throw off your balancing if you didn't, right? Okay, I'll give you a few minutes on 3 and 4 here, and we'll look at those. Okay, what kind of reaction are we looking at for number 3? It's a combustion reaction. It's the only kind where we have a hydrocarbon reacting with oxygen. What are always the products of a combustion reaction? Right, CO2 and H2O. All right, since I didn't get any ionic compounds or special elements, I can skip the checking for those swapping and dropping steps. Okay, now I got to go straight to balancing. Do I have special balancing rules? Do I need them both? No. 3 is an odd number, so I don't need the rule of 2 for this one. So starting alphabetically, 3 carbons. 3 carbons. 8 hydrogens. 4 times 2 is 8 hydrogens. And then for my oxygens, 3 times 2 is 6, plus 4 more is 10. 5 times 2 is 10. Okay. Questions on that one? All right, and our last one here. What kind of reaction are we looking at there? Double replacement. Okay, it's 2 ionic compounds. All right, in a double replacement reaction, we're told really all you have to do is swap the metals to get your new products. So that means that sodium is going to end up with chlorine, and hydrogen is going to end up with hydroxide, making water. Okay, this is an acid-base neutralization type of replacement reaction. Okay, where we add a strong acid to a strong base, and when you do that, you end up with water and a salt. That's why it neutralizes. Okay, it's provided you have the same amount of both. All right, so now that I've got those, I need to drop and swap. This is a -1, this is a +1, so we're good there. Hydroxide's a -1, hydrogen's a +1, so we're good there. There are no small numbers anywhere in this, so it's already balanced. Okay, how are we feeling about this predicting stuff? Good? Okay. So sometimes I give people a flow chart, but I've started going away from that because I found people used it as a crutch way too much. Okay, and if they lost this sheet of paper, they were lost themselves. Okay, but I don't think from what I'm seeing from you guys that you even really need this. Okay, there's 5 steps to follow. Okay, we identify the type, we use the type to predict the products, we check for special elements, we drop and swap ionic compounds. I think I said that in a different order this time, but that order doesn't really matter. Okay, and then we balance the reaction last. It's always the same 5 steps. Okay, we can remember those 5 steps, and we know our 5 reaction types fairly well. Okay, this really isn't all that difficult. Okay? In fact, when I give the final assignment on reactions, the part on the 10 questions on prediction are usually the best 10. Okay, the part where they have to write it out in words is the part that's really bad always. I don't know why, and it seems like that would be the easier part. Okay. All right, try those ones there, please. All right, so on number 5, okay, what kind of reaction are we looking at? Synthesis, yeah, we got 2 elements reacting to form a single compound. So that's the pattern. That means I got to do this. Okay, BEI2. Now, whoop, I got ahead of myself. BEI. Okay, then I got to check for special elements and drop and swap. I don't have any special elements. Now I got to drop and swap. This is a -1. This is a +2. Now it's BEI2. Okay, do I need to do anything else? It's already balanced. Okay, so we're good at that point. What about for number 6? What kind of reaction are we looking at there? Single replacement. We have an element reacting with an ionic compound. Okay, now on this side here, okay, because this is a metal, it's going to replace iron or oxygen. It's going to replace the iron. That means iron is going to wind up alone, and potassium is going to wind up with oxygen. Okay, do I have an ionic compound there? What do I need to do with it? Drop and swap it. Okay, so this is a +1, this is a -2, so I'm looking at K2O there. All right, and is iron special? No, it has more than one possible charge, but that doesn't affect what we're doing here. Okay, it's not a special element that needs a small number beside it. Okay, now I've got to balance this whole thing. Okay, what's the only thing out of balance right now? Potassium. What needs to go here? 2. The rest of it's good. Okay. How many people have done 7? What kind of reaction is 7? Double replacement. Okay, so in a double replacement reaction, I have 2 ionic compounds reacting, and what I'm supposed to do is swap the metals. So that means that magnesium is going to end up with sulfate, and copper is going to end up with chlorine. All right, now, this reaction illustrates something that's pretty important, okay? Copper has more than one possible charge, yes? It keeps that charge between the reactants and the products. It's not going to change, but I still have to figure out what it is, okay? Now, on this particular one, it's easy enough to figure it out, okay? I got, this is a -2, this must be a +2 because they're 1 to 1. Everyone okay with that? So then I go back over here and I go, okay, 2 plus, 1 minus, CuCl2. Okay, look at this one, this is a -2, this is a +2, so that one's okay the way it's written, and the reaction is already balanced. All right, now, sometimes you might run into a reaction like this. A single replacement reaction. I'll just have you guys write this one down just because it's good to go over it. So I get a single replacement reaction. In this case, copper is the element, and it's reacting with lithium nitride. So in this single replacement reaction, copper is going to replace lithium, right? Okay, so I get copper with nitrogen. I get lithium by itself. I'm supposed to drop and swap this. Which charge do I use? Did they ever tell me which copper this is? No. They didn't. Okay, and because it was an element, it wasn't either one yet. Okay, it doesn't become copper 1 or copper 2 until it's in a compound with something else. Okay, even if this was written out in words, it would say copper reacts with lithium nitride. It wouldn't say copper 1. There isn't copper 1 until it's in a compound. So, here's the rule. You go with whatever charge is listed first in that situation only. Okay? In the situation up here, I was able to figure out which copper it was. If I can figure it out, then I do. Okay? If I'm in a situation like this, where I have no way to figure it out, then I go with the one that's listed first. The reason for that? It is by far the more common of the charges. Okay? The first charge is the most common charge. Often we're talking more than 90% of the time, it's that charge. Okay? So what's the most common charge on copper according to your periodic table? 2. Okay. So then I would go 2 plus, 3 minus. Okay, lithium's not special, so I don't have to do that, even though I've just hurt its feelings. Okay, and now I've got to balance the whole reaction. Okay, now, what should I balance first? Even though I've got 3 lithium here, I also have 3 copper over here. Okay, if I balance the lithium, am I going to have to change the number? Yes, because nitrogen's a 2 over here, isn't it? Okay, so if I just go, oh, I'll put a 3 here, I'm going to come back over here and have to balance my nitrogens in a minute and change the number anyway. Agreed? Okay, I'm going to balance the nitrogens. Okay, how many lithium does that give me? 6. Okay, and I knew the copper wasn't going to change. I could have done copper first if I wanted to, but it wasn't going to affect anything else. Okay? That is as tricky as they get. Okay, when you've got a single replacement, I said to you all along, single replacement are the ones that are the trickiest because you got so many things to remember and so many weird situations that can come up. Okay. All right, what have we got left here? You got 8, 9, and 10 left. How many people have done 8? I didn't have 9 and 10 on the board yet, so okay. All right, let's look at 8. What kind of reaction? Combustion. What are always the products?
CO2 ratio.
All right. Okay, do I need both rules for this one?
Yes.
Yes. Okay, so for this one, I am going to use a 2 here to start, rule of 2. 2 times 4 is 8 carbons, so balancing alphabetically. 2 times 10 hydrogens is 20. 10 times 2 is 20. Okay, and then looking at my oxygens, 8 times 2 is 16, plus 10 more is 26. 13 times 2 is 26. I think we've done that particular reaction now about a half a dozen times since we started. Okay? All right, I'm going to give you a few minutes on 9 and 10. We'll walk through those, and then we're going to do the pre-lab activities for tomorrow's lab. All right, what kind of reaction am I looking at on number 9? Decomposition. I only have one reactant, so okay, it's going to split up into rubidium and phosphorus. Okay, there's no swapping and dropping to do there because there's no ionic compounds on the product side, but what is there? A special element. Which one? Phosphorus. What does it come as? Right. Okay, now we got to balance this thing. 4 is the biggest number. Okay, so I'm going to put a 4 in front of rubidium. That gives me 12 rubidiums. 12 there. Balances the rest of the reaction. Okay. Questions on that one? All right. For number 10, I've got lead 4 chloride, okay, and that's just me automatically kind of doing that one in my head. This is a -1, okay, because lead has more than one possible charge, so there's 4 negative charges. That means this has to be the +4 lead, okay, and it's with cobalt 2 phosphate, I believe. Okay, this is a -3, so that gives me 6 negative charges, 6 positive, yeah, so it's +2. Okay, so it's a double replacement reaction because they're both ionic compounds, okay, and I've just got to swap the metals. So cobalt is going to end up with chlorine, and lead is going to end up with phosphate. All right, both of those have to be dropped and swapped. Now, I've already done the heavy lifting on this side, okay, to figure out what the charges on those 2 multivalent metals are, which is important. Okay, this one we said was going to be a +2, and this is a -1, so we're looking at COCl2. Okay, and this we said was a +4. This is a -3, so a 3 is going to go here. Then I'm going to need brackets with a 4 outside of the brackets to make that one work. Okay. This is about as hairy as a double replacement reaction is going to get for you. Now I need to balance the whole thing. What should I start with? I'd start with phosphate. I've got 2 things that are 4s in there, but phosphate has a way bigger charge. And as we said last week, the bigger charge is going to affect the rest of the reaction a lot more. Right? So 4 on that side, I need to put a 2 here to balance my phosphates. When I put that 2 there, that gives me 6 cobalts. So I'm going to come over here and put a 6 in front of cobalt. When I do that, it gives me 12 chlorines. So I go back over here and put a 3 in front of this to make my 12 chlorines, which happens to work out because there's 3 leads on the other side. Okay? Always a good sign when the last number you put in works with the one number that doesn't have anything yet. Okay? All right, how are we feeling about this stuff? Okay, we kind of got to build on this a bit. Okay, it's going to take some time. This is probably the most important skill going forward in this unit, being able to know those 5 types, predict the products of a reaction, okay, because it's going to be important for our lab.